Hello. Today I will present the final project that I did for my natural language processing course, which is the spam detection project. And so this is the introduction. Uh, First, I will show you where I got my data and how I cleaned up my data. And then I'll show you some visualization about how my data looks like. And then I will introduce how I extracted the features and which model I chose for my spam detection project. And lastly, I will compare the evaluation of my model. To start off, I got the data from a website called Kaggle.com, which is one of the most famous online community for scientists. And if, as you can see here, I got an actual spam email data set, which had 5,700 rows, and the data looks like this. So there's a raw text which contains both the subject and the content, and there's a label, either 1 or 0, and 1 means that it's a spam, and 0 means that they are non-spam. Okay, next I processed my data by first dividing the raw text into the subject row, the subject column, and the content column. And then I used the regular expression tokenizer from NLTK to tokenize my text. And finally, I used the Porter stemmer again to tokenize, I mean, to take the stems from my tokens. And the difference between the stems and tokens is that the tokens are just the exact words from the text, while stems are the root words of any words. So if you can see, like here, the word naturally is the actual text from my raw text, and when you stem the word naturally, it turns into a nature. So basically, you're just taking the root form of every word. And the reason I used stems is because the model might take advantage of stems because different forms of words get normalized into simpler forms. And I thought that would be useful for detecting spam. And before we move on, I wanted to show you the visualization of my data. And so here you can see the blue graphs are the non-spam emails, while the red ones are the spam ones. And the x-axis represents the length of the text, while the y-axis are the counts of the spam, of all the emails. And, oh, sorry. And if you look at the content part, you can't really tell a difference between the content, but if you look at the subject here, you can definitely tell that spam emails tend to have longer subjects. Also, I checked out the value counts of my entire data frame, and there were about 4,300 non-spam emails and 1,300 spam emails. And it looks a little bit unbalanced, like the count of the dataset. Yeah. And moving on to feature extraction, I used the TF-IDF vectorizer to extract the features from my raw data. That's because I assumed that TF-IDF would be more suitable in my case, because if you would just use the bag of words, they would only count the frequencies of the words, but like as you can see here, tell by its name, TF-IDF stands for term frequency inverse document frequency, and basically what it does is that you can put more weight on the less frequent words. So I thought that spam emails usually have some words that you could tell that it's spam. For example, like the word money or like the word free. And so I wanted to put more weight on those kind of words. And that's why I used the TF-IDF vectorizer. And now with the vectorized features, I fed them into this model called the multinomial naive Bayes classifier. And this model is popular in machine learning for especially for text classification, such as spam detection and like sentiment analysis. It also has an advantage dealing with sparse matrices, and which sparse matrices are just the matrices that have a lot of zero values in it. And usually vectorizing the text usually end up being sparse matrices. So that's why this model is good for text analysis. And finally, I will show you how my model did with some comparison of the stems and the tokenized words. So first, the stem text did a pretty good job, where the highest average score was 91%. And it shows that the subject actually played a greater role than the content when determining if it's spam or not. And one special feature about all three models is that if you can see, the recall scores are like really, really low. And I thought that was because, so first of all, the recall here refers to the score of how much the model predicted as spam out of the actual spam mails. And I thought that the low score for recall is because of the unbalanced data that I had before. There was like 4,000 non-spam, while there was only like 1,700 spam mails. And that's why I think the recall scores got too low. And so next up is the tokens that I used to train, and actually they were worse than the stemmed words, because they all had an overall accuracy of about 77%, and like before, they all had a low recall score. This one got even a 0. And so we can conclude that the stem text actually did a better job than the tokenized text. And the reason for that is because I thought that like emails could contain some variations, like such as typos or like slang words that you could use in the emails, whereas spam emails are really formal and they like follow a format. And the variations to the non-spam emails might make the model more confused, and that's what happens here. Because tokens just take the raw text form, while the stemmed words are the root of every word. And that's why I think my model using the stemmed words did a better job. And the recall score might be just because of the unbalanced data like you've seen before. And so this is it for my spam detection project, and thanks for watching.